as you probably figured out by now in your past science classes, is that scientists like to categorize and classify things. And it's the same is true for chemical reactions. There tends to be patterns in the way atoms react, or compounds and atoms react with each other. So if we can classify different types of reactions, it helps us find patterns and predict how other things will react. So that's where that becomes useful, especially when we get into the next part, predicting products. If you can figure out what type of reaction you're working with, you can anticipate what you expect will happen because you've seen other reactions that do that same thing. So the first type of reaction that we're going to do is called a synthesis reaction. Now, a synthesis reaction is when you have two or more substances that combine to form one new compound. And typically it's two elements combining to form a compound. One other disclosure as you're filling out your notes is that your note packet may be different in the order that we cover these. I believe it is. So if you have to skip around a little differently, that may be something you have to do. Okay, so we got two or more things coming together. So what you'll always have is two reactants going to one product. So you'll have two things on one side of the arrow, one thing on the other side of the arrow. So an example would be sodium plus chlorine combining to form sodium chloride. So you got two things on the left side forming one thing on the right side. Now there's a generic equation. So for the first four types of reactions we'll cover, I'll give you a generic equation like this. So basically you got A plus B. So let's imagine them here. They're separate, and what they're going to do is they're going to combine and form a single compound. So A plus B, they start separated, they'll end up together. That's the generic formula for a synthesis reaction. So you can almost think of it like two single people getting together, now they're a couple. Decomposition reaction is essentially the opposite of a synthesis reaction. A single compound will produce two or more simpler substances. It doesn't necessarily mean that it'll break up into its individual elements, but it will break up into simpler components. So you'll always start with one thing on the left side of the arrow, and it'll break up into two or more products on the right side. So an example is potassium chlorate. It breaks up into potassium chloride plus oxygen. So our generic equation here, you got AB, a compound AB. We bring it in. What it's essentially going to do is break apart, and you're going to be left with A plus B. Now, one thing I want you to know when you look at these, the AB, the compound here, no longer exists. It becomes these things here. So if you look at the bottom, so the AB separates, the AB is gone, and you're left with the two components separated. So a lot of times I find that students have a hard time grasping that this becomes this no longer exists after the reaction happens. A single replacement reaction. This is where you'll have an element that will come in and replace a similar element in a compound. So you'll have an element that's on its own, but it'll come kick out an element that's in a compound. See what the generic kind of form here, or one of the ways to recognize this is you'll always have an element plus a compound. It'll make a new element and a new compound. So there will be two things on each side of the arrow. So that's one way to identify it. Now here's an example. You've got aluminum. In this case, aluminum is my element. So I've got my element, aluminum here. And then I've got a compound. And then what's happening here is the aluminum is a metal. So it's going to kick out, it's going to replace. This is why it's called a single replacement. We've got a single element that's going to come in, kick out the element in this compound. See, copper's on its own, and then you're left with aluminum chloride. And I always recommend drawing these arrows to help you visualize it when you're identifying them, just to make sure you're doing it right. And it says one element replaces a similar element. Because this is a metal, it will replace the metal in this compound. There is a scenario where we'll have a halogen here, and the halogen will replace the halogen in the compound. We'll talk about that more later. But just know that make sure you identify what type of element. Is it a metal or a non-metal? If it's a metal, it's going to replace the metal. If it's a non-metal, it will replace the non-metal in the compound. So the generic equation, you got A plus B, or AB compound, plus C, the element. It looks like this. What's going to happen is C is going to replace A, so A is now on its own, and you've got a new compound that's called CB. In the order that they're written, if you put CB first and A second, kind of like it is down here, doesn't matter. I don't care which one goes first if you're writing them out, as long as you have the correct formulas on the correct side of the arrow. Double replacement reaction. This is when you got ions of two or more compounds. They exchange places to form a new compound. This is a very common reaction. You'll see, and when we do labs, if you went back into all our labs that we've done already, you would start to recognize that a lot of the reactions we were dealing with were double replacement reactions. So in this case, it's also two compounds, the two new compounds. It's similar to the single replacement reaction, that there's two things on each side of the arrow. But in this case, it's two compounds. If you remember from the single replacement, it's an element plus a compound goes to a new element plus a new compound. But there are two things on each side of the arrow for both of those. So two reactants goes to two products. So example, you've got NaBr, sodium bromide reacts with aluminum chloride. Typically, the best way to solve the double replacement reactions is just swap the metals out. The first element in each compound, swap them out. You'll notice the aluminum is now with the bromine. The sodium is now with the chlorine. So here's how our generic equation looks. So we've got two compounds. We bring them in. Take the first element, so C and A, and swap places. And so now you're left with AD plus CB. So here's a summary. Take a second to identify these if you want on your own. So in the first reaction, you've got two separate things coming together. That would be a synthesis reaction. One thing breaking apart is a decomp. Then this is a single replacement. The C is going to come in, kick out one of the elements here. It leaves B on its own. Here you've got two compounds going to two new compounds. So notice for these two, there is a subtle difference here. There is two things on each side of the arrow, but this one's a compound. I thought I drew a C there. Compound plus an element. This one's a compound plus a compound. It's not like in the C's there. Okay, so compound plus element, compound plus compound. There is one more type of reaction, so if you want to draw this out, you can, just as a nice review or a little reference sheet. There is one more type. This one was probably the one that was out of order for you on your note outline. The combustion reaction. This one doesn't follow the nice bubbles like the other one does, quite as nice. But it should be a pretty easy one to identify. It's whenever you have carbon combining with oxygen, and it'll release a lot of energy. So anytime you start a campfire, you light your Bunsen burner, those are all combustion reactions. They're carbon compounds combining with oxygen to give off a lot of energy. This one also is a 2-to-2 like style reaction, two reactants to two products. It's typically hydrocarbons burning. So a hydrocarbon is a compound of carbon and hydrogen. That's where the hydrocarbon name comes from. An example is C3H8 goes to, so this is propane plus oxygen gives you CO2 plus water. Now, anytime you see a carbon-hydrogen compound here, you should be thinking combustion. And then just to confirm that it is a combustion, this chunk here, the oxygen, CO2, and H2O, are dead giveaways that it's a combustion reaction. That will always be the same. So the generic equation is CH, a CH compound. The X and Y can be, put whatever numbers you want in there. Plus O2 goes to CO2 and H2O. A lot of students think this is they mislabel this as a single replacement because they see a compound plus an element. But make sure you can identify that this is a combustion, not a single replacement. So take the time to look at this, compare it to your single replacement reactions, because you do end up with a compound plus a compound, which is not the same as a single replacement. So those are your 5 types of reactions. You should be able to look at any given reaction and label it as one of these 5. To simplify things, we do use abbreviations. I'll quick give those to you now. S stands for synthesis. D stands for decomposition. Then we use SR for single replacement, DR for double replacement, and C for combustion, so that when you are identifying all these reactions, you don't have to write out single replacement, double replacement every time. Use these letter codes to save yourself a lot of time.